So, over to you, James.
Thank you very much, Simon, and thank you all for coming along. So, I live in a little village called Littlejohn, and I've had that handle since Twitter existed because I was living in Silicon Valley, Mountain View at the time. And in 2006, I think it was, I returned because I wanted to be decentralized. I'd been hanging around with this new thing called Amazon Web Services. So I could come back to a little highland village in Aberdeenshire and I could have as much compute power as the people I'd left behind in Silicon Valley. For some reason, I went against the cloud then. I wanted to do peer-to-peer text mining. So I think it was 2012, I went back to the Strata conference, and there were only 2 people speaking about peer-to-peer there. It was a guy called Jeremy Miller, who invented the XMPP protocol, which sits behind all the chat, and me. But what we didn't know at that time was there was a guy called Satoshi Nakamoto. And not being in the crypto space at that time, it took me 3 years to get there. Anyway, in July this year, I joined the Cyber Academy, which is part of the School of Computing at Napier University. And I've done that because from my networking travels, they are the smartest people in the lands of cryptography, not just in the UK, but globally. So they're helping me with my ideas. So I thought there'd be 3 parts to the talk tonight. A bit of education, followed by a demo, go into the IoT health, followed by a demo, and then go into wearables and do a demo. Because there's a lot of mystique about this blockchain thing, so I think just by seeing it multiple times, hopefully some of the terminology and what it means more. So let's start with some education. Let's go back just over 400 years ago. There was a prevailing belief that the world was flat. And the early scientists, as we call them now, through the logic and reasoning and measurement, started to fathom out that this might not be the case. However, it was a risky business. So there was a risk of death if you asserted that the world was round back in 1600. And this is the surname of a famous scientist. Can anybody decipher it? It's an example of what we call a Caesar cipher. No? Nobody's been to my talk before? I see a few people with keyboards. So if you were to take the letter N and go 1 to the left, you get a B. And if you take a T, you get an R, and you follow that, you get Bruno. Giovanni Bruno, burned at the stake in downtown Rome in 1600 for a certain. I tell this story for 2 reasons. One, to show that cryptography has been part of society's governance for a long time, and also to make the point that it does have a bedrock in the encryption in Bitcoin's case, SHA-256. So I know that other speakers are going to adapt what these mean, but I just thought we'd set the scene. So a hash is just saying you take a big string, say of like 1,000 words, and give yourself 120-bit string of jumbled up numbers. And if you were just to change one little dot in that 1,000 words, the hash would look completely different. And this is what a Bitcoin transaction is. Transactions are gathered into blocks. The blocks come to be because of a process called mining. So I should have asked, how many people have got Bitcoin in their wallet right now? Ether coins? No. Safe coins? No. Color coins? No. Cool. So how did these coins come to be? So if you were looking for some gold, what would you do? You'd have to go to some rock and get some dynamite, drills, and you blast it. You gather up the ore, and you put some heat, some more energy, and then you distill the gold, and you might make it into a little nugget. And at some point in time, that was worth $1,000 or a few $100. So Bitcoin, we don't mine for this ore of gold. We mine for big, large prime numbers. And so Satoshi Nakamoto just created this abstract mathematical game called Hashcash ×2, which just says every 10 minutes there's this hard problem to solve. And the hard problem you've got to solve is just fire numbers at it at random. And it will tell you if you've got the right number for this particular puzzle. And right now I think there's 30,000 computers, many supercomputers worth of energy going in to find these every 10 minutes. So this gave us this mechanism to join blocks, and this is called proof of work. Right now, I was talking to someone earlier, I said I could give you some money on my credit card and then run, and eventually the banking system would catch up with me. But if I was to give you 10 Bitcoins, we could have cryptographic proof that right here and now, at a peer-to-peer transaction, I have those coins to give to you. And if I didn't have 10, the transaction would go. And tonight, now that we've got the basis of a simple monetary contract, projects like Ethereum and Rootstock have now given us this notion of a smart contract, which is just a computer program running on this blockchain infrastructure. So just what does it give you, all this technical stuff? The mutability, you can't go back and easily change the past. Some would say now there's such a level of difficulty in Bitcoin, you could maybe do it for a few days, but it was so economically and computationally intensive that well, no one's succeeded to date. There's no single point of failure. There's these 30,000 nodes across the. And the point I try and sort of just bring it all together, it's not just cryptography, it's not just software rules, it's human psychology, it's game theory, it's this new something, and no one actually has got a scientific definition of what it is, but what we do have is a problem solved, which was how do you have consensus on a distributed network. That was a fundamental problem in computer science, and now Satoshi has solved that. But we don't understand all the bits that make up the logic to do that. So time for a demo. So I thought we'd do two things tonight. I thought we'd build a transnational bank and then a transnational health service. So we're going to start with the bank. Any guess how many lines of code it takes to build a bank?
20.
Yes. Is that plain? Yep. That's probably a bit small. This is an example of a Solidity contract, version 4. We're up to 4.2 today. And if you're a computer programmer, you'll see it just looks like an object. And if you're familiar with JavaScript. So all we're saying that this metacoin we're creating needs some seed capital. Decided to give it 300,000. The basic setup, we had the banker and we have a simple two-person peer-to-peer network. And what we're going to do is create the contract. So the banker, which is the top one, created the contract. So here we have the smart contract initiated, and this node here is going to mine for these cryptographic numbers to verify that this transaction is now part of the blockchain. And here we see, yes, it's mining already. So we now have our coin with this 30,000 balance, or 300,000, in existence. So the next thing we need to do is send the money from the base capital to the customer. So the customer is this person in the bottom right. So I think we're going to send them, we're just checking that, yeah. I think we'll just check that the customer has no balance because there's been no transactions, just to verify our contract's truthful, yeah. So now we have to put in our public key to the customer. I should have said I had planned to do this live tonight, but I wiped my hard disk drive, but luckily I recorded this 5 minutes before.
Saki wasn't a Bitcoin wallet.
Well, my Bitcoin wallet is on there, but I do have a backup for that.
Okay.
So here again we have a transaction. So what we're going to do here is check the balance, because the 300,000 should be lower and the customer's balance should be 201. And we'll notice the numbers never changed. Does that mean why that was a bug in my contract? It wasn't accepted because it required a function to be certified by the blockchain. So anytime you change state in Ethereum, that costs you something. It's called gas. So now that it's been accepted into the blockchain, now the money has been cryptographically certified and this will go down. Now this goes on to create a central bank showing quantitative easing, but for time. Okay, so we've done our bank. What problem are we trying to solve with IoT? So Bitcoin had solved this double spend problem. So does IoT have a double spend problem? To some degree, but I don't think it's the heart of the issue. Ethereum builds on this proof of work, the concept of gas, to keep these contracts. So if you have thousands of computers and you've got a big compute job, and they're all going for free, you would just use them, right? So there's a cost, and that's part of their economic incentive. Our friends across the train want to monetize our hard disk that drives at home, and they call it proof of resource. And I think we've got a lot harder job when we combine IoT sensors into a health or wellness or whatever context.
I didn't hear what it was.
Why? Because just because we can account for these things immutably, it says nothing about the honesty or the trustworthiness of the content that's actually been saved. So you could have garbage content certified immutable. It's still garbage content. So I think our job in IoT and is to keep the data honest all the way through the stack. So a few of us have created this pyramid. So yes, it does involve some component of blockchain, but it involves some tools in cryptography at the sensor level, hooking into our data stores, whether it's secure central ones or these new decentralized ones, governed by smart contracts, what we call utilities. And then my particular project is automating the verification of any science or the truthfulness of anything in a broad very sense. So going back to our sensors, there is a fundamental weakness that nothing is secured directly from a sensor onto a blockchain today. There's always some human or some automated way which could be interfered with. But even worse, even if we tie that down, cryptographically speaking, the guys at Napier did a demo based on the electricity power going through the laptop, took my public key. So that's just by monitoring the electricity. And if it's a Bluetooth connection, they can intervene Wi-Fi and microwaves. So the reason they do hack proactively at these technologies is because then they stand back and say, what can we do defensively to prevent them? So there's two schools of thought running on here. One, the people at Napier are working on, which is the whole notion of a zero knowledge proof. And the best way I like to describe that is saying, if you were wearing a pacemaker, probably even the ones today, but especially five years ago, there was no certainty anyone could hack the protocol. It was open, just like our Bluetooth today. But even worse, they couldn't certify that the software that was running on it was giving the amount of beats that they asserted that you should have. And again, even through a bug or through an attack, that can be manipulated at will. So the idea is you can put the zero knowledge proof in the clock. And all the zero knowledge proof saying, it's like a heartbeat. It will complete the cycle of a clock. And if it does that, it can do a handshake to a blockchain. And over time, you can get this audit trail of what the capabilities of the sensor is. And then I've got this open source wearable to my phone, to the blockchain, and that's just not happening. But the crypto people are working on mobile clients, and I think once this mobile clients become secure, I think they'll help us liberate the wearable data directly into the blockchain. Whereas the example you'll see tonight is me batching my log files from my open source XYZ accelerometer data and making Merkle trees and storing them on a reference on the blockchain. So let's see that working. Just skip the workflow. So this time, the point is the patient, and is it playing? And the blue is the clinician. And again, very simple private network, 2 people. Right, so I play the violin. I also play football and skiing, and sometimes or play badminton, that's sort of number 1 thing for my wrist. So I sprained that one, broken. Cool feature of my laptop has got an extra machine built into it. And so what this is doing here is saying these are smart contracts to machine learning algorithms which are already registered on the blockchain. So putting together my whole X-ray, it's going to my account. It's like I don't want to mark my own homework, so I'm going to get the clinician's account to mine to verify that into the blockchain. It's done. The thing about smart contracts, the ones I'm showing you now are just like one standoffs, but what we're working on now is you can call other smart contracts. And this is when things get complicated in the new frontier. So I've delegated permission access to the doctor, and he's given delegated permission to the radiographer, and the radiographer's delegated permission to the machine learning algorithm people, which could be anywhere on the planet. So the doctor's looked at the X-ray machine learning algorithm and said it's broken. He thinks it's broken. He confirms a diagnostic, which hits the smart contract. And so when the patient clicks on this, he's calling so when we're calling, we don't have to mine, and it's certified as broken. And of course, the story doesn't stop there. I heal or I don't treat. So you have the next X-ray coming in to be certified, and this is building up an evidence chain, which over a large enough populace, we can make assertions whether this technique we chosen to heal my finger was actually the best one, given all the other options pinning. So of course, So the purpose of these sensors is to give you certainty over the scientific certainty over the outcome. And so right now, if we aggregate all that data over a big enough set, that if we could sample on a random basis across that network and always get the same results, then we could have some reassurance that the algorithm is good. But I think this is a good example of like the decision stops at the clinician level. Or as I mentioned, I'm a violin player and I wear my wearable. So I'm out in the pub every Tuesday. So I've got that pattern in my history. Now that I've recovered from my finger, does that pattern become back? That's what I ultimately want, isn't it? I don't want to not play my violin anymore, if possible, right? So this is the last demo, is taking data from this wearable, which I collect via a laptop, into files. I then take a hash of each file, and I do this Merkle tree process. So I've got 8, and then I have 4, and then I have 2, and then I have the root. And I do that for multiple files. So I've got lots of files, and I do the same for that. And then once I've got that magic number, I put it into a smart contract. And that gives me proof of data. It just says that if I want to run this experiment again on my accelerometer data, I've got cryptographic proof that all these points came from my wearable. this example starts by me registering the sensor onto the blockchain. Time's up. Just about there. So now I've got an identity between me and the sensor and the data and this script at the bottom. Let me get there. It's basically doing the hashing. Just to prove that the data is coming in. So in this example, not only did I hash it, I also saved it to my MadeSafe account. So again, slightly contract, just storing the hash of that tree and my MadeSafe URL. Just forget the code. So that's basically where all my data files from the wearable are stacked. And so I'm just calling this script to do all that work that I described. It's now looking to record it on the blockchain. The blockchain accepts it, and now I've got my address, so I've got the money. Right. Just a little bit back. So we have got mountains of challenges on IoT, healthcare, and if anything out with a simple monetary transaction. But the cyberpunks keep on giving. These zero knowledge proofs are also called snarks, and I'm sure there's other things that are going to come along. It's still early days out with the financial sphere, so let's get these test projects working on things like living cohort studies as a replacement to clinical trials, and getting some research in mental health and blood pressure. But my sort of moment of eureka, epiphany with Bitcoin was, having looked at it for a second time, was the realization that we started with a bit of history, that 4,000 years ago the first entry ledger system came to be. And I say, well, what other technology or logic underpins society in such a wide and pervasive mechanism today? We now just have this 21st century version of double entry ledger keeping, which we're still understanding, but I think of equally as dramatic. So thank you.